Okay, I think we should get started maybe. And you can tell if Jenny's on, right? I mean,
I can't.
she would just.
Jenny, are you there today?
All right. Well, she spoke up last time, so hopefully,
Yeah,
will let us know. Okay, so secondary data analysis. This you can't see so well, but this is what not to do. Get all the information you can and think of the use for it later. So just out of curiosity, when I say secondary data analysis, what do you think of versus primary? Like what
I'm thinking like you got your data and you sort of did like a cursory look at what's happening. Maybe it's partway through a study, and secondaries maybe after you have a better idea.
Afterwards.
Yeah.
Okay, good. So I'm going to clarify. First, just to kind of show you the schematic of how I view the flow of study implementation. So we start with the study hypothesis, which is the core of the scientific method, right? Start with a study objective. And then come obtaining the data and designing the study design. And I sort of think of these as sometimes the data comes first, sometimes study design comes first. They kind of feed off each other. Now, what I mean by that is sometimes, for example, you are stuck with the data you have, right? You have a rare occurrence. You're looking for cases of dental implant failure. They don't occur so often or whatever it is. Mm-hmm. So you are really reliant on whatever data you have. And then because of that, you have to, let's say, you don't have time to wait for it to happen. So you have to develop some kind of case control study or cross-sectional study. Okay. However, sometimes your study design feeds into your data. So if you are intent on studying incident cases of something, you're just going to have to obtain data longitudinally. So that in that case, study design will be the important part of the objective, and then the data, that informs the data. And of course, then we have the analysis and publication or whatever end goal, there is. I kind of put this together because we're going to think about this in terms of some of the data sources we have. So we're going to go back to this schematic. Okay, so definitions. So when we talk about primary and secondary data collection, data analysis, we're not so much talking about your role as the researcher in the primary, secondary. We're talking about where the data were obtained, how they were obtained, who initialized, like who initiated the data collection. So technically, primary data analysis is data analysis conducted by the research team that originally collected the data to analyze it for the original hypothesis, the original purpose. Okay, so you set out to find out about dental implant failure. You are the primary research team, researcher, PI, and you go out and collect the data from patients or records. That would be primary data collection. Secondary data analysis and collection would be that you are analyzing data that was collected by another research team and or for another purpose. Okay, so let's say your mentor, whoever you worked with, wanted to collect information about dental implants for a whole other hypothesis, right? And they that mentor collected the data, has everything ready, and you come along and they're like, great, you want to look at dental implant failure? Why don't you use data set I already collected? Yeah. That would be a secondary data analysis.
Yes. Okay.
And the distinction is not huge, and it doesn't mean anything in and of itself. It's just that it involves kind of different approach and a more comprehensive approach when it comes to kind of making sure you understand the data, what they're there for. Are they really going to be able to be used for your purposes, given that you didn't collect the data, right? And what is our approach to data that we didn't collect, but now we want to analyze? So advantages. Main advantage, it's done. Money, time, right? That's a huge advantage. The second main one that I would identify is that often, and especially in epidemiologic data sets, which I'm going to distinguish in a second between epidemiologic versus clinical, there are a lot of variables and outcomes collected. So like if you're to look at, a long-term NIH-funded study, there are going to be so many variables collected that either might suit your needs as a researcher or might not, but there's this breadth of, you may not have thought to look at socioeconomic status in your data set, but if it's there, you may be like, whoa, that's interesting, or that's another confounder I hadn't thought of, or, so the breadth of variables tends to be broader in these large data sets. And then quality of data. I wrote here higher, but it's not always higher, so it depends. It depends on what data you're utilizing. But I'm going to get back to this, the difference between the epidemiologic and clinical data.
Sorry.
No problem. We're talking about secondary data.
Great.
Analysis. So, and we'll get back to this in a second. Disadvantages in using secondary data. And by the way, Danielle, for definitional purposes, I'm defining secondary data analysis as analysis done on data that you did not collect, okay? Or that were not collected for your objective. Disadvantage, the first one is actually the flip side of the advantage. The study design and data collection were complete. That could be great to save you time and money, but it could be not great if you, let's say want to continue collection, or if they didn't really collect the data you want, right? It's done oftentimes and you can't add to it. Sometimes that's not true. And we'll talk about why. So for example, this Haynes study that we're going to talk about, the CDC very large continuous survey study, you can actually apply and suggest items for them to include in subsequent years. So there are, and that is a very efficient way to obtain data, is to tag along to an existing study and get your additional questions asked, or biomarkers collected or whatever. A second disadvantage is that the data is might be inadequate for your research objectives. So you could think of all sorts of examples of this, but let's say in terms of, again, I'm picking on Todd, but dental implants, if it's just kind of survey questions, have you had dental implants? Have they worked? Did they, that self-reported information may not be enough for you. So it's really important to ascertain but you have to balance that with your needs as a researcher, or your needs to, develop some preliminary analysis so you can pursue another pilot. So sometimes secondary data analysis can fit in as a really great tool for preliminary analysis that might launch to something else, right? So that's an important thing to keep in mind. And the last thing is the data may not be clean, and often it isn't. And what I mean by clean, and we're going to talk about this a lot, is that it might be difficult to translate to the form that you require, okay? Or it just may not be clean in that, I don't know if you guys ever use data from the National Death Index. It's a disaster, it's a nightmare. Medicare data is a nightmare to code and clean, and it comes very messy, right? Because they're administrative data for the most part, and to some extent clinical data are collected this way. They're not collected with the researcher in mind. They're collected for administrative purposes, sometimes clinical purposes, but so they're not clean in the sense that we think of them as clean as researchers or as analysts, right? So that's something to keep in mind and to work into. This is very important, to work into the timeline that you need to analyze it, right? So oftentimes researchers come along and great, this, it's ready. I can write this paper in a month. You cannot write any paper in a month and analyze the data and all that. So usually data are not clean. Yeah.
Sorry, this is a bit of a
tangent. Yeah.
Tangent.
Go ahead.
But I have been trying to figure out the National Death Index. What is the way that you? I can't figure out. I have found some sources online that will let you search the Social Security Death Index via their platforms using a name and birth date, but that doesn't seem like the right way to do it.
Right, well, what's the purpose you need it for?
Like overall like long-term survival of
Of particular,
particular
like,
patients, like, yeah. And
I don't know. So you're
there was
saying-
like an IRB,
Yeah.
you know, a study done here, and all of the patients were enrolled, and they like had scans, and they correlated their like scans with
Right.
with like different gene, and this was like 5 years ago or something
Right.
like that this happened. And like part of it was that we were going to later do a like long-term follow-up survival.
Right.
But
Are
like,
you- so
our
there's-
chart,
Yeah,
our charts don't have great survival data. So I've been told to like try to look at the Social Security
national.
Death Index.
and there's no
Which-
IRB issues with people who have died, right? So you could just look it up.
Yeah, and I have like found these sources online that will let you like just look it up theoretically through the Social Security Death Index, but like I don't know that is.
I would go to the vital statistics. We could talk about it after
Yeah.
class, but I would go to the vital statistics like website, the official website, and even contact them. What we used it for is we linked up data that we already had, a data set, to find out the mortality of our participants. And we received permission for them, the National Index did the linkage with our participants' social security numbers and sent the data back to us.
Got it.
And I believe we didn't get social security numbers back.
Got it.
That may have been our agreement with the data set rather than the National Death Index.
Got it.
You may also be limited on some of those sites, I don't know, but you might be limited in terms of getting information on cause and
Yes,
death codes and
Totally.
stuff like that, and so.
Yeah.
but when you
going through
apply
them-
to it
Yeah.
formally
Yeah.
and you get it approved and you get it sent, you
They'll
can get a
send
lot
you
more
a
information.
copy,
Yeah.
Okay.
Now, it's so messy, so we started doing it. I was like, why are there multiple deaths for the same person? Like, I
Yeah.
didn't, they'll link to people, the way the National Index gets coded is like they link to people based on their social security number, their dates of birth. But in some cases, for example, a spouse who's linked to her husband's, let's say, social security will get the same social security number will be used. So I've seen it where her death, this woman's death, is coded in her spouse's name. Like, it's so, I don't know how they function over there, but in
That's
these
crazy.
data that we got were so crazy and messy that we ended up not using them. But I would contact the Vital Statistics office like directly and see if
Okay.
you can do it officially. From my experience, the more effort you put into it and get it more officially gotten to you, it'll be cleaner than, unless they have a really great system set up online. But we can talk about it further after.
Thanks.
Okay, so that is a good lead in to the secondary data sources. Okay, so first type of source, so I'm kind of defined it into two ways, epidemiologic and non-epidemiologic. What I call epidemiologic is data sets that were created for the purposes of research. For example, NIH data, CDC data,
And CPD.
and CDB's data. They were created, various data repositories. So some of them are sort of borderline, like the renal data, like USRDS, right, with renal data, is probably for clinical purposes, but they also have research in mind. So it's kind of like in between epidemiologic and not. There's SEER data on cancer. There are a lot of sources that can be utilized for research purposes, and they tend to be cleaner. They tend to be have somebody sort of, or an office or a coordinating center connected to them, so you can, reach somebody, or either they have a great website or they have someone to contact. Non-epidemiologic sources are a bit different because, like I said, they were not collected for the purposes of research for the most part. Medicare data, hospitalization data. It might be that certain institutes or hospitals are more sensitive to the fact that these data might be used for research, but I haven't seen hospitalization data really set up for researchers. So it takes manipulating and it takes more cleaning, and they're not as broad in terms of what's collected. Another source of non-epidemiologic data is non-health data. So for example, the census. We use the census data a lot to, so I'll give you an example. I'm interested in neighborhood socioeconomic factors. So what we'll do is we have a data set, so like an NIH, long-term, like longitudinal cohort study, and we wanted to know if the neighborhoods in which these people live affect their health. So we linked their residential addresses, residential address to the census. And then we get back, and the linkage is done, like de-identified and by the coordinating center, then we get back the data. Those data are census data, so they're not set up for health, but it doesn't mean you can't use them. So there are all sorts of interesting, creative sets of data out there to use. One of the chapters in my dissertation was looking at neighborhood level crime and how it relates to chronic disease. In that case, I wrote it on chronic kidney disease. So, and I looked for crime data in the neighborhoods that were relevant to my participants, et cetera. So there are different ways to kind of go about looking for non-research-based or epidemiologic data. How do we obtain secondary data? So there are kind of three main categories that I wanted to cover. EHR, well, we could talk about where we think it falls. Okay, so the first is public data. So like I said, the NIH data, CDC data, all these federally funded data sets, and often state-funded data sets are public, okay? You do not have to pay for them. Oftentimes, you have immediate access to them. So if you went to the NHANES website today, you could download the data and begin your analysis. Like, it's available to you right away. There's another data set that I'm going to introduce you to today called MIDAS, and you can also download the data today, start using it, okay? The upside is that it allows for immediate use. The downside is that anyone can immediately use it. So there's more research competition, right? You could be writing the same paper, the same analysis as somebody else this second, and you wouldn't know until they publish their paper, which is fine. That's the, freedom of ideas and research out there, but it's just something to keep in mind.
But in some ways, it's like interesting, right? I know that there is this tendency to not necessarily publish something that's already been published, but like we kind of should, right? If two people are looking at the same data set, trying to answer the same question and get different answers,
yes,
or the same answer, I think then it's like both are useful. Yet I know it's not.
No, it's. So I'll tell you what's
publication.
No, it's. When I first started out, I was under the impression that I was always looking for something new that totally no one ever looked at.
Right.
And I'm going to discover some, association or disease that no one ever thought of.
Yeah.
But that, the way science works is that the more we replicate, the stronger our conclusions. We have to replicate studies.
Right.
Now, would I pursue the exact question someone else asked in the exact data set? That probably wouldn't be that clever. You do it with a twist. So more often than not, there is a difference in how you do it. Mm-hmm. And that's really appreciated in the research world. So, for example, if, I'm working on, I'm really interested in looking at the epidemiology of PCOS, right? Now, some studies have looked at that. However, very limited data sets, very non-generalizable, mostly not in the United States, right? There's so many twists that I can have that would be a contribution.
Right.
But you do have to determine your contribution.
Right.
And I can tell you, and maybe Heather's had this experience too, a couple times we're like about to, submit something, and I'm like, oh my God, this group did basically the same thing. Now it's near statistically very unlikely someone did the exact same thing as you did. Okay. Right. So you are almost always going to find a twist, but still that's really important it's important to know the literature. It's important to do a literature review. But public data, there's always that chance. So what I would do is you get yourself familiar with the researchers who have been working in this area, and sometimes you reach out to them. And a lot of time, like part of the culture is to collaborate. For the most part, I find most researchers are collaborative. And so you kind of want to keep up. You might even want to be in touch. Like it's really important to network from that perspective.
Right.
The second type of data sets are not quite they're public to some extent, that they don't cost money, but they require a proposal. Those are a lot of the, for example, NIH-funded studies that are not meant to be public access, but are still public in that they're federally funded, so that we're technically, they're technically free. So, for example, I don't know if you're familiar with the ERIC study, atherosclerosis risk and community study. I'm mostly familiar with cardiovascular disease studies, like Framingham, right?
Mm-hmm.
Or cardiovascular health study. The MESA is the multi-ethnic study of atherosclerosis. We're going to talk about it. Midlife in the U.S. study. All these studies, actually Midlife in the U.S. is public. So, but SWAN is the study of women across the nation, women's health across the nation. Those are studies that are, they're based in a coordinating center, and the data is based in a coordinating center, and that you can submit a proposal, which is usually kind of a 1 or 2 page thing. It takes about a month to 3 months, let's say, to get a response, get the data, and you can go ahead and work on it. Now, in order to do that, it's a bit time consuming, but once you get approved, your topic is protected. So if I submit a proposal to MESA, for example, or to Cardia ERIC, whatever one, any of these, and we'll talk about a couple examples, and they approve my topic, they will not approve someone else on the same topic. It is protected to me. Now, they follow up with me every 6 months or a year. Where are you with your thing? And if you're not like producing something, eventually they will ask you to withdraw. They'll put you in touch with people who have really similar interests. It's a really, I find, like overall positive thing that this happens, because it does allow for collaborative efforts and for some protection for research interests. But I wouldn't shy away from studies that require proposals, because they're really a great resource. And then the last type of secondary data sets are private, and those generally require purchase. And these will be, all these kind of big data sort of sources from corporations or all sorts of things. I mean, I rarely use private data. I think that they are often not clean in the research sense, because they're collected either to sell or for admin purposes. And oftentimes I don't think they're worth the money. So you don't be so quick to purchase data till you know that there isn't something out there that you can get otherwise. Where does EHR fall in this? I have been thinking about this a lot. I don't know quite, I mean, it's not private. It's probably public, but it's not public to anyone, right? So it'll be
I would call it private.
It's private.
It's owned
by the hospital.
the
Or by,
hospital. Yeah,
I would
owned by the
also-
health system.
I would also not call it secondary. I think
Correct.
It's a primary data collection. So if you are collecting these data on the dental implants from medical records, that is a form of primary data collection. So that it probably doesn't fall into any of these. But let's say your mentor collected the data and handed you to them, that is probably private, right? So if no one else has access to them but you, then it probably should be considered private. Okay, so we looked at this flow before, and Danielle, I'll just orient you. So the top box was like our study hypothesis. So I'm going to give you an example with the data set that I mentioned. Have you guys ever heard of NHANES? So it stands for the National Health and Nutrition Examination, National Health and Nutrition Examination Survey. It is an ongoing CDC study, and it'll be I'm going to introduce you to 4 epidemiologic data sets today. So I'll talk more about what it is exactly. But I'm just giving you an example of the flow of how you would orient yourself around obtaining a secondary data set. So let's say this is a public data set, and let's say my question, which was a study that I had done years ago, is education level associated with awareness, treatment, and control of hypertension. Okay, that was what I wanted to look at. And now, how do I obtain the data? What are some of the issues? So my first thing was I familiarized myself with the literature, right? Is there potential overlap? Has someone looked at this in NHANES? There have been a lot of papers on education and hypertension in NHANES, but no one really looked at awareness, treatment, and control, so management of hypertension. So I thought this would be interesting. Obtaining the data was relatively easy. It was something I could do right away off the website. But then there were a couple of other issues with the data. One is that often surveys have their own unique analytical issues. So one of them is weighting. So weights are often used in surveys to account for either oversampling or undersampling or people who are missing. And very sophisticated data sets like NHANES, they have already created these weights. And there are certain ways to use them. And so, for example, in NHANES is meant to be representative of the US population. That's one of its strengths. But in order to make it representative, you have to utilize the weights analytically. So it's really important when you obtain data like this that you are familiar with all the analytical issues that come along with it. One of the dangers of public data is that there's very little oversight. Now, in a peer-reviewed journal, there should be people who review your work and say, like, wait, did you use weights? Did you, But A, a lot of journals are not peer-reviewed today, and B, a lot of reviewers miss this. So I find a surprising number of poorly done methods with regard to public data because there's less oversight. So that's really something to keep in mind. You want, just because the data are available in there, you just want to keep in mind that you are aware of what to do with them, and your analyst is aware of what to do with them. Okay, so study design. So there are a few issues. NHANES, for example, NHANES is a data set that has, every 2 years, they've collected data on about 10,000 people every 2 years. But these are not the same people over time. So it seems when you look at NHANES and they're like, hypertension levels between the year 2000 and 2016, you're like, whoa, that's longitudinal. When you read the methods, they're not longitudinal. Oh. It's waves of brand new people, right?
Yeah.
That is technically cross-sectional, even though multiple waves can suggest something longitudinal. But unless they're the same people, they're not truly longitudinal. So it's really important to keep in mind the limitations of the data. Now, it's very, very, very helpful and useful to have waves of data over time, even if they're not the same people. The same people are ideal, but even if they're not, but you have to keep in mind it could be cohort effects that you're seeing. It could be other things that's not longitudinally based. The other issues with study design that come up, and I tell you this out of trial and error, is defining your exposure and outcome. So different waves in NHANES define education levels differently. So, we collected all these data, we did our exclusions, we were supposed to have about 35,000 people in the final data set, and I'm looking at the education variable and I'm thinking, why are there only 25,000 people? It turns out a whole wave was set to missing because the education variable had a different name. These are really small, admin type mistakes, but they're hard to catch unless you really get very, very, very attentive at the beginning of a study. And then your analysis plan, going back to the data, will really have to be tweaked to the specific data set. And so you'll want to be aware of the unique analytic aspects of your particular data set. Okay, so that's an example of just the flow of how you would, start dealing with a public data set. What about a data set requiring a proposal? So one example is SWAN. SWAN is the study of women's health across the nation. It's a data set that actually the coordinating center is here at UCLA. our colleagues work on SWAN. Have you worked on SWAN? Did you? No. And it's a study that recruits women who are I believe they're perimenopausal, and follows them up over time. Now, the difference between, I'm just going to point out the differences in how you would go. You'd go about the same thing, right? Study hypothesis, setting up your data, making sure you understand the data set, and we'll talk about a little bit more about what to look out for with secondary data. The difference is in yellow here, that you want to look at potential overlap, but you want to look at potential overlap of other proposals that had been sent to SWAN. So every coordinating center for these kinds of studies will actually have a list of their approved proposals. And so you want to contact the coordinating center. You want to find out the publication committee, submit your idea, ask them if there's like a search engine. Often there's like a search that you can look through, and actually look through the different proposals and see if anything overlaps. Because again, a proposal might be in the works and not near publication, so you're not going to find it on PubMed, okay? And you don't want to waste your time writing a proposal when one has already been approved, right? So you want to be as knowledgeable as possible going into the process. And then you request the data access by submitting a concept proposal to the publications committee. That, depending on the study, can take a while. That can take anywhere from like 1 month to 3 months. It's a bit time consuming, but if you have the time, meaning if you need to produce something for a class in the next 6 months, don't do this. But if you have the time and this is a bigger study and a bigger project, I find it very worthwhile. The data sets are often in great shape. And then even after the analysis, you have to stay in touch with the coordinating center, because before, let's say you write your whole paper or you write an abstract or you prepare a poster for a conference, you actually have to get approval from the parent study. And often it's not very rigorous, but they want to make sure that you've done, that the methods look generally okay. And the process is quick, but they have to approve before you publish, because you're publishing it in their name, right? You're saying this is the SWAN study. Some of them will actually require you to send the code to them to review, and that's really more intensive ones. I mean, only certain ones do that. Okay. So what about once you obtain the data and you want to start conducting the secondary data analysis? What are the things to look out for? So the first thing I very, very strongly want to emphasize is become very familiar with the original study, all the details. You don't have to necessarily read them up, but read as much as you can online documentation. There are so many examples I can tell you of like pitfalls that just were due to like a lack of familiarity with the actual study. So I'll give you an example. MIDAS, which is one of the studies we'll talk about today, the way they recruited is that they recruited participants, and then they asked the participants if they have siblings or twins. Also, they specifically looked for twins and then recruited their siblings. So we have a data set now that has a good number of sibling pairs. Okay, now why is that relevant? Because when you do analysis, you want to account for clustering by family, right? So that's often very relevant, especially with anything related to genetics, or I mean, almost everything. So all our analyses are run using these models that account for clustering by family. If we didn't know that there were siblings, right, we would have fallen into this trap. And it's public data. So I'd be doing all the analysis and maybe a reviewer would catch this, right? Hopefully they would. But this is something that you have to be really familiar with. The second thing is use the code books and the data documentation. Okay, so oftentimes these studies have really extensive documentation and they're very, very useful. Go back to it, go back to the questionnaires, assess the assays and the calibration over time. Different waves, as we mentioned before, will utilize different assays. You have to know if you need to calibrate or if they have calibrated variables. So, you know, you're looking for blood pressure, right? Or sorry, let's say you're looking for CRP, okay? There might be 5 different CRP variables in your data set. One is calibrated, one is this unit, one is that unit. You cannot just tell your analyst, for example, use CRP. You're the one who, as the PI, who has to determine which of the variables. That's not something an analyst should be doing. Unless it's obvious, right? But it's usually not. And another example of the code books and the data documentation is your sample population. So one of the things we're going to talk about with data coding and cleaning is one of the biggest tools to use is to look for the N, okay? Just the sample size number. The sample sizes will tell you, they'll be the big red flags to why all these people dropped? Like, what's my flow chart from the beginning? How come I started with 14,000 and now we're at 8,000, right? So, I mean, I was actually consultant on a project recently, and the main study was 16,000 participants. And by the time we got to the analytic study, they were working with 8,000 participants. And I was like, okay, what happened to all those people? And she's like, I don't know, but this is a big sample. I'm like, no, we're not doing that. You just dropped almost half your population. Yes, 8,000 is a nice number, but you know, there could be massive selection bias. And it turns out that we had all those 8,000, so we were linking hospitalization data, and all those 8,000 people were hospitalized because the people who were not hospitalized, like who did not experience a hospitalization over the time period, simply didn't have a record. It was missing, but missing should have been coded as no hospitalization. And instead it was coded as missing and they all dropped out. So we have this sample of 8,000 people who are obviously not generalizable, right? They're all the people who've been hospitalized. And it could have been a massive like mislead. I mean, maybe we would have caught it eventually, but that's not something that you know that's obvious until way later, right?
Right.
So it's really important to do this up front. That's what I'd like to emphasize. Like, it's worth the time and the effort that you put into prepping your data, understanding it, getting it ready for analysis. In fact, when you go back to that schematic of this, you know, that I did at the very beginning, all your time should be spent before you get to analysis. And the analysis that's not the hard part, right? It's the cleaning, it's the, you know, it's getting it ready. And the more ready you are, the better the results will be. And frankly, like, you'll be able to move quicker. Okay, so we talked about analytic guidelines for surveys. So there's certain analytic guidelines, for example, using weights, data set updates. So let's say you use, you know, this MESA study that, again, one of the studies we're going to talk about. They, in the coordinating center, they update their data sets all the time. They do not send alerts out to all the investigators. Like, you have to just, you know, not constantly, but once in a while, hey, am I using, you know, I'm doing this study that I've been working on for the past year and a half. Let me just check if this is the most up-to-date data set before I run the final set of analyses, right? So just something to keep in mind, that things change constantly. Usually not dramatically. Usually it won't really affect your exposure and outcome, but it might. And so you have to be aware of it. And the last thing here is, I would say, preliminary analyses. Make sure you are clear about the exposure and the outcome. Even run a quick frequency check of your exposure and outcome so there isn't something egregious. It could be that your exposure is not popular, even though the code book states that they have, you know, information about whatever it is, socioeconomic status. It could be that no one responded to the income question. And then if that's your main exposure, that's a problem. And then missing data. Missing data we'll talk about more when we talk about coding. But you want to know what's missing, why it's missing. We did a whole set of analyses on heart rate variability using MESA over 6 exams. And we realized that a lot were missing heart rate, and they were all missing from exam 2. And it turns out in exam 2, they had started this study and basically forgot to do the heart rate part, and then remembered sort of halfway through. And a lot of people at that second exam were missing heart rate. So, you know, you kind of, sometimes you miss this and it comes up later, but the more you check your main variables, the better off you are. Okay, so common pitfalls we talked about a lot of them: identifying the correct variables, the changes in the different waves, using study-created scales. Okay, this is a big one. I'm going to show you an example of this. So oftentimes a study will create the scales that you might be interested in. So for example, a scale of comorbidity, okay? That's fine, that's great if they created the way you wanted, but you have to check how it was created because it may not be what you think it is. Okay, so don't take things at face value, understand the definitions. Subcohorts are interesting, they happen sometimes. So for example, in Midas, they realized after recruitment that most of the population was white, and they wanted to include African-American participants. And only in the second wave did they recruit about 500 African-American participants. So that's fine, that's the way the study was done, but you have to be aware of that the second wave doesn't really have the baseline information. So if I'm gonna compare race, race outcomes, I don't have that for baseline. So you have to be aware of that, or else you're gonna be pretty far along before you realize that in terms of like using these data, and you don't want to be stuck that way. Awareness of population sample and the data set updates we talked about. Okay, I'm going to give you an example of something that happened in Midas. This is midlife study in the US. So let me give you an example of choosing the correct variable. Okay, so we wanted something simple. We just wanted race, ethnic, race, ethnicity from Midas. Okay, so Midas 1 was the first wave. They had two ways that they collected data in Midas. One was a phone interview, and one was a self-administered questionnaire, the SAQ. And in the first wave, they only asked about race and ethnicity in the self-administered questionnaire. And they started off with these two questions. What are your main racial origins? That is, what race are your parents, grandparents, and other ancestors? Circle all that apply, okay? These were the options here: white, black, or African American, Native American, or okay. So these are all the options. And then the second question, asked of everybody, no skip pattern: what race do you consider yourself to be? Okay, so your background. And then there were a whole slew of others. Do you want to marry a person of the same race? Do you think it's important? How comfortable are you with people of the same race? There were so many questions. Okay, so these were the main ones that we thought would identify somebody. All right. Now, in the second Midas, and this is harder to read, but I'll tell you what it says. So the second Midas, they collected this by phone, not self-administered administered questionnaire, so it's already different in terms of how it was collected. The first question they asked is, what is your main racial origin? That is the race or races of your parents, grandparents, and others. So that's similar to that other question. The next question is, which do you feel best describes your racial background? Okay, different than the last question. And the third question, which best describes your race? Those second questions are already different than the question in the first wave. Okay, not only that, I don't know if you noticed this, but there are skip patterns suddenly. So here is, what are your main racial origins? If there's multiple mentions, ask the next one. Don't go to the next one if they only answered once. Okay, so most people who will answer once will just have this main racial origins question, as opposed to Midas 1 where there weren't skip patterns. Okay, so this is small. You have to catch this. Now, if I didn't catch this written in the questionnaire, the way I'd catch it is because this variable would have a ton of missing people. I'd be like, wait a second, what's going on? And then my first thing when I see a lot of missing is I think, was there a skip pattern? Okay, now I'm stuck because I want to know race, ethnicity in Midas. I have two waves. They asked it totally differently in wave 1 and wave 2. What do I do? So we look and we said, okay, we want to see in each wave, what was the question they asked that had no skip patterns, okay? And what closely resembled as much as possible, like what they think what they describe themselves as, what they identify with. So for Midas 1, it was the question, what race do you consider yourself to be? I would have loved for them to just ask that of everybody in Midas 2, but they didn't. And this is secondary data analysis, so I have what I have. And so the second, for Midas 2, the closest question like that was, what are your main racial origins? Okay, so we settled on those two. One from the self-administered questionnaire, one from phone. By the way, let me point out, in both ways, totally different variable names. Okay, so you have to be aware of that. Okay, this is very hard to read, but I'll show you what we did here was just a crosstab. So this is the -1 options, white, black, Native American, and these are the -2 options. Okay, now white and white are the same, black and black are the same kind of names. We have Native American, Alaskan Native, Eskimo. Here, we don't have Alaskan Native. This category is Asian or Pacific Islander. Here it's separately Asian, Native Hawaiian, Pacific Islander. We already have different groups. Now this wasn't so important in MIDAS because there aren't so many here, so it doesn't matter. But I have to be aware of that. I'm suddenly going to have to group, collapse based on totally different categories. Okay, so that's one thing to keep in mind. The other thing is there's a conflict. Okay, some people who said they were African American in the first wave said that they were Native American in the second wave, or said that they were white in the second wave. Okay, there's now that's not completely impossible, right? So, but you as the researcher need to determine what are you going to do about this. Are you just going to pick one wave and go with it, which is a possibility, or are you going to get all this information and try to make the best of what you have? So for example, what we did here is if people said that they were two different things in different waves, we considered them multiracial, and we made that another category. Okay, so it's, in this case, it's 90% white. It's not so complicated, but it can be complicated. And in some cases, it can be completely like impossible. So we have in MIDAS 2, we asked them their highest educational level in the first wave and their highest educational level in the second wave. And okay, someone can improve their education, but usually don't go backwards, right? So we have people who in the first wave said they were a college graduate, and the second wave said they were a high school graduate, okay? So what do? Do you throw out those data? So in those in the cases where it was egregious enough that they were 2 education levels off, we set it to missing. But we had to make those arbitrary choices, right? And we had to document those choices, and that's the important part. Just know what you're doing, document it, log it, and you can always go back and make different decisions later. Okay, this is very dense, but I wanted to give you an example of creating scales and scores. So we wanted to look at comorbidity in MIDAS. Let's say you want to look at that. MIDAS has all this great documentation, and they already have a score for the number of chronic conditions in the past 12 months. But I want to know how it was created before I decide to use it. So I look at the documentation, and I see that the continuous score is based on the total number of chronic conditions that the respondent checked to have experienced in the past 12 months. Now, it tells me here the questions that they answered, okay, A to CC. I want to look those up because I want to know if those 12 conditions are the ones that I want to include in a scale. Okay, so that's the first thing I'm going to look at. I want to know how it's constructed. Is it an average? Is it a count? So it turns out here, it's constructed by taking the total number of yes responses. So that's a count, okay? So if they responded yes to 5 chronic conditions, the score is a 5. But what about missing values? What do they do if someone did not respond to the heart disease question? Not that they said no, but they did not respond. So in this case, it's computed for cases that have at least one valid response to questions in the summary variable. So their criteria was, as long as someone responded one of the 12, we're creating a score for them, okay? Which means that if someone responded that they have 5 diseases, 5 conditions, but they responded missing to heart disease, we assume that they do not have heart disease, right? Because we are assuming a 0, because if you add it up, you are assuming a 0. That might not be an assumption you want to make, okay? It might be an assumption, it might not be. You have to decide. That's a form of imputation. That's a form of, you need to realize all the consequences of what you decide to code. In this case, given that the prevalence of heart disease is relatively low in a healthy population, that's probably a good assumption to make. If you don't have that assumption, or if you have an older population, or you expect a certain number to have heart disease, that may not be a great assumption. You may want to make another decision about imputing missing. Okay, so any questions so far before I'm going to spend the rest of the time introducing you to 4 data sets? No. Okay. So these 4, and there are many others, but I think these 4 are good examples of, and Haynes and MIDAS are great examples of public data sets, and then CHS and MESA are good examples of the data sets requiring proposals. In this case, both of them funded by NHLBI at the NIH. So the first one is NHANES, and we talked about it a bit. It's the National Health and Nutrition Examination Survey, funded by the CDC. There were a bunch of different NHANES studies, but in the current form, the most similar one began in 1988. That first study was actually a survey done over 6 years, between 1988 and 1994. And after that, they were done in 2-year waves. So again, these are not the same people, but the latest continuous, the latest NHANES survey is 2016 to 2018. I believe they're in the middle of the 2019 one. And they're pretty amazing in the numbers. So they're meant to be representative of the US population. There are about 10,000 people represented in each 2-year wave. So there are about 30,000 in the NHANES 3 in that first set for over 6 years. The age range is all ages. So they include very small children who have, who I don't think they have blood drawn, but they have some of the examination done, and they ask questions of a parent. And then they have, all ages going up from there. The race ethnic groups that are represented are primarily non-Hispanic white, non-Hispanic Black, and Mexican American. Those are the largest groups. And there are a really, really rich set of data. So they have them come in for questionnaires. They have these MEC units. MEC is the Mobile Examination Center. They literally have these trucks that drive around. And in it, they do all the examinations. They draw blood, so they have lab assessments. They have oral health examinations, they vision, everything, literally like anything you could think of. So it's really, really worthwhile, I think, this data set in terms of especially preliminary analysis. So again, it's cross-sectional, but let's say you need to know, the prevalence of X in the US population. This is a great resource. So elements of the data are demographic, diet. It was meant to be a nutritional health assessment in the beginning. So they have a really rich set of dietary data, examination data, laboratory questionnaire, and then there's a limited set of data, a limited access data, including youth data, mortality, and geocoding. That means neighborhoods that people are from, that are more sensitive, and so they're not sort of public access. You do have to submit a proposal. In some cases, only analyze the data on site in NHANES, or they have like a very restricted data server. And so these data are available, but they're more restrictive. And then in terms of accessing it, it's really fairly simple. So what's not great about NHANES is you cannot speak to a human. It's almost impossible to speak to a human. But their data sets, their websites are very, very comprehensive. So if you just Google NHANES, you'll see a data set like this, a website like this. You'll have all, you could look at it by questionnaires, all the different data variables that are available, and then the years. So this is NHANES 3, that 1988 to 94 data set, and then these are the 2-year waves. And in each of these, you'll find the questionnaires, the exam laboratory procedures, the brochures, the code books, the documentation, everything's in there. They have very comprehensive survey contents, and I just gave an example. So that big PDF files, 1999 to 2016, in one file, you have like all their table of contents of everything that they have. So it's a very useful file to look at if you just want like a quick overview. And then they have frequently asked questions, which are very, very useful for NHANES, especially with like the analytic guidelines and what you should be doing to like account for the weights and all that. And that's just an example of one from one of the survey years. So I really recommend, if you ever, are in need of sort of some preliminary analyses or a study, a cross-sectional study, these are very useful data.
You mentioned that they use, a number of times you mentioned that they use weights in the data set. We see a lot of data that don't include that. And so we have some sort of cross-sectional data set or even any data set really, and we don't often weight it. When is that indicated? And
so I'm not an expert in weights, but my understanding is I only use it for NHANES and other similar surveys. When you do so for example, if NHANES claims to be representative of the US population. If you want to lay claim to that, then you need to account. They didn't do a perfect job,
right.
So they accounted for what they thought was lacking in terms of they oversampled some groups, they undersampled some groups, what they thought led to like missing groups, they accounted for in weights. So if you have the idea is that if you want to state this is a representative sample, you should be using their weights. Yeah.
Okay. So to make it more generalizable. To make
it more generalizable, exactly. There are other reasons to use weights, but I think for your purposes, it's mostly to be encountered in big surveys like this. In your own data that you're going to be collecting, or like you don't have to worry about those. Okay. Yeah. Perfect. Okay, the second example of a public use data set is MIDAS. MIDAS is a little less well known. It was established by the MacArthur Foundation and then taken over by the NIA, the National Institutes of Aging, in 2002. It was set up as a longitudinal cohort study. So now we're talking about multiple waves of the same people, right? The main objective was to look at the psychosocial, behavioral, sociodemographic correlates with aging. So it had to do with particularly following people up in terms of aging. What's very unique about this study is that it includes biology and a very rich set of psychosocial factors, which is rare. So you'll see often, so for example, the cardiovascular disease data sets that I'm most familiar with, they'll ask some questions about, psychosocial measures, nowhere near what they do in MIDAS, okay? So, all those race ethnic questions that I mentioned, that's MIDAS. That's a typical MIDAS thing, whereas other studies will just ask one question. It started with about 7,100 people, and I'll show you a schematic showing more about how it was set up. But actually, this is not correct in that we have now a third wave. So there's MIDAS 1, MIDAS 2, and MIDAS 3. But the downside is that they each have 10 years in between them. So that's a big lag of time for a longitudinal study. The age range is pretty wide, 24 to 74. And they were recruited from across the US, but it is not claimed to be representative of the US. Okay, so while they didn't go to specific counties, they went to, they kind of recruited from across the US. They didn't recruit from everywhere. And it's less common to use weights. I think MIDAS itself didn't develop weights, as far as I know, right? They don't, so we don't really use weights in MIDAS. The access is public. You can download from the University of Michigan has this data repository called the ICPSR, and it's actually a great data repository to sort of become familiar with because they have all sorts of data there, but that's where the MIDAS data are housed. So just to show you, and this is a really good example of like kind of sub-cohorts and the complications of some data sets. So this is the first wave of MIDAS, 7,100 participants. 4,963 participants showed up or were recruited from this original group 10 years later, okay, that came back. However, that's when they realized, you know what, we really need some African-American participants. So they recruited 592, they all come from Milwaukee, okay? So that's a big that's something that is a big factor in when we do racial disparity assessments in Midas. We do them, but we always have to acknowledge that this entire population came from one place, right? So we can never tease out if the effects we're seeing are based on the fact that they're from Milwaukee or that they're African American. Okay, there's no way to tease that out. So that's one thing to keep in mind. So now you have this 5555 in Midas 2, but remember the Milwaukee participants were just started here. So the Midas 1 questions were not all asked of Milwaukee. Some of them were, they just asked them 10 years later. So for example, childhood socioeconomic status, they were asked about, but at Midas 2. So I need to know all this because I need to know where to look for the data. They're all over the place, right? And so it's going to take quite a while to get this together, get it organized, either do this along with my analyst or do this on my own and become familiar with this. It's a very complicated data set to become familiar with. But once I do it, it's free, I have it, I can analyze it. And then the other part of Midas is that what they did at the second wave is that they did multiple different projects where they recruited all the individuals at Midas 2, but they didn't take all of them, right? So they did these 4 different projects on this, pooled from this sample, right? So extracted from this sample. So one project was called the Daily Diary Study, where people were asked to write down a diary basically every day of their stressful experiences over the course of a week, and to take salivary samples and assess their cortisol levels and all that. So that was a project 2. Project 3, there were cognitive assessments done. Project 4 is the big project that we use often, is where biomarkers were assessed. So we only have biomarkers for Midas 2. We do not have any biomarkers at Midas 1, okay? And then Project 5 was a neuroscience, like an imaging sub-study. So this is just an example of some of the things you can get from Midas, but not everybody was at everything. These are the kind of more detailed information about each project and each wave and what could be taken from, and you can look at this later. And this is an example of how you extract the data. So you just go to the ICPSR website. It actually gives you quite a lot of preliminary information about Midas, explanations, and then you can, link. All you have to do is set up a login. Where's that login here? So you create an account and you set up your login, and then you can just download the data immediately. And they have it in SAS, they have it in SPSS, they have it in Stata. So again, it's very easy to get, but you have to become familiar with it before you kind of utilize the data. Okay, so those are 2 examples of public data. Now what about the data requiring proposals? So the first is the cardiovascular health study. This is a longitudinal cohort study funded by the NIA, NHLBI, I think. And it was one of a set of 3 studies that were meant to kind of be parallel studies to each other, but across the life course. So Cardia, that Heather is very familiar with, recruited participants ages 18 to 30. Eric recruited middle-aged participants, and then CHS looked at the older participants. So they recruited individuals from Medicare eligibility lists. So everybody, all the participants in CHS are on Medicare, okay? That has advantages and disadvantages, obviously. They're all 65 and older. They're 81% white, 16% African American, and very few other race ethnic groups. There are 10 exams, and they're basically, the follow-up is about 10 years. There's another kind of weird thing with an African American cohort that was recruited somewhat later on in the study, so they were similar to what we saw with Midas. And this study was recruited from only 4 US counties, okay, so 4 counties in the US. And then access to the data is via a proposal and approval from CHS. So just to show you some of an example, and this you could see when you look at their website, but this is the baseline. The second exam took place 3 years later, and then every year after that, okay? And so some of the measures, this isn't all of the measures. So for example, some of them, every single year they asked about self-rated health. Okay, education was only asked about at baseline because education is not likely to change for people who are 65 and older. Income was only asked about baseline, which I think is not that great. Depression was, income was asked about at baseline and then again a couple times later, but not at every wave. So that's something to keep in mind. Depression was asked about almost every time, actually. Blood was taken incrementally, so not each time, but baseline, year 5, year 9, 10, and 11. Okay, so when you're doing these studies, you need to know, like, yes, I have 10 exams, but it doesn't mean I have blood from 10 exams, right? And at year 5, by the way, that's when the African American cohort was recruited. So for them, it's a shorter period. Year 5 is their baseline, not year 1. Which again is not, all these can be accounted for in analysis, you just have to know what's happening. Okay, and then the last study that we can, I'm going to talk to you guys about the homework and feel free to ask any questions about these. The last study is a study that I use a lot, and that's the only one of these that's really ongoing. Actually, NHANES is ongoing, so is MIDAS. Okay, so compared to CHS, it's ongoing. This is a study of the multi-ethnic study of atherosclerosis, similar in setup to CHS, longitudinal cohort study, out to examine the determinants of subclinical cardiovascular disease, but a lot more diverse in terms of the participants. So participants are ages 45 to 84, so it's also a middle age group, about 6,800 participants at baseline, and they, it's only 38% white, 28% African American, Chinese and Hispanic groups are also included. So it's a lot more diverse, and that's been very, very useful because there are not a lot of studies on cardiovascular disease risk factors that are this diverse. They have, actually now it's 6 exams, this is not updated. So baseline began in the year 2000. The 6th exam was just completed in 2018. And they're recruited from 6 US communities. And access is the same thing as CHS. It's via a proposal and approval from MESA. So just to show you some of the different measures, you could see here, there's personal history, there's all sorts of medical history and medications. And then there's the A there indicates an ancillary study. So that's when a group of researchers said, you know what, we want to take a subset from MESA and we want to analyze some sleep measures, right? We want to look at some sleep measures. So that's, you see the little 2,500. So of the 4651, they took 2,500 participants and recruited them for this sleep study. So that's a great way to get participants, and you're within the parent study. But you have to know when you are kind of looking for data, what are, is this a subsample? Is it the entire sample? So that's part of becoming familiar with the data set. And I just kind of gave you a whole list. I think this is a very useful study. Again, just because the objective is cardiovascular risk factors doesn't mean you should shy away from a study, because often there's a lot of things to kind of dig into. Because there's this captive group who've been asked a lot of questions and a lot of procedures done on them. Okay, so this you can look at another time. The final 2 slides are really a list of, so the DAP is something that's kind of dead in the water right now. It's the Data Access Project, which is a project that we started at...
Sorry, why is it dead in the water?
I'll tell you.
Oh, you're getting there.
I'm getting there.
Sorry.
It's dead in the water because...
Wait a second.
No. Well, maybe it'll be resuscitated. I don't know. So it's part of a project that we did at the geriatrics division as part of the Pepper Center, which is the Older Americans, what does it stand for? OAIC.
Older American Independence
Center. So it was a center that we were funded for that hopefully will resume at some point. As part of that, we created this project in order to kind of help and guide early investigators and junior investigators in using epidemiologic data sets. And so my colleague and I at Geriatrics were kind of providing this service to get people acclimated and acquainted and help them identify different data sets and kind of apply them to their use. So these are the data sets that we worked with, this slide and the slide before that you guys can look at. If you're interested in any of these particular studies, Dr. Meiwa Wang and I have a lot of experience using them. And so we can, you know, it's worth kind of going through I mean, a lot of these, it may not look like they're useful to you based on their names, but if you are interested in secondary data and obtaining it, I'm happy to talk about different options with you. So I just kind of provided the list in case any of these sort of ended up being useful or of interest. So just in terms of the next couple of classes, there's homework due on Monday that, I think Monday, right? May 6th, yeah. And now it's sort of connected to we kind of redesigned the curriculum, the syllabus this quarter compared to last year. So it is connected to the study design class, but it's also in preparation for your project. So the idea is to just identify one journal article that you're going to be using as a reference for your final project, and just describe, I said a slide, you don't really have to create a slide, you can just create, you know, a document where you just describe the study design of that journal article, the data collection, the study design, and just summarize like the study design, right? The recruited sample, where they come from, what's the study design. And that will hopefully get you going for the next assignment for the final project, which is to describe your own study design.
Is it more important that the topic is relevant to our project, or that the study design and analysis is related?
Oh, I was saying that just to use one of the references you might use for your project, okay. But you can do any, really. Yeah.
If there's one that you think, if there's someone that did something similar to what you're going to do,
yeah,
it's a good process to think through how did they implement it. So what would that mean I would do? Okay.
Yeah, I think in your case that might be a good thing to do.
Okay.
Because we were talking about that last time.
Yeah.
I think that will be worthwhile.
Right. So it's probably better that it's that as opposed to like the same topic.
Right?
Yeah.
But if you have a reference that's,
I think maybe I'll try and chase down one of each sort of.
Yeah.
Because I know of examples where they've evaluated this issue, but it's really qualitative and not very clinically informative.
Right.
And what I'd like to do is find an example of somebody looking at maybe perhaps something totally different, but that has already done the whole methodology and analysis.
Yeah, that's a good idea.
Hard work for.
Yeah, that's a good idea. Because then hopefully you can apply it to what you want to do. Yeah.
And just wanted to let you guys know that I've taken a first scan at your background and going to make some comments. I'll pass along to Sharon, but it'll probably be early next week by the time you get the comments back from us. But
right,
looks good, and so appreciate you.
We like to do it together so that you guys don't get two sets of.
Right, exactly.
Yes. Yes.